Okay, welcome back. We're going to talk about 1.3, basic classes of functions. A lot of this is vocabulary, but there are a few things you need to know operationally with function arithmetic, and I'll highlight those to make sure you've got it. Okay. When we speak about classes of functions, you should know many of them, such as linear, quadratic. Those should be your two most familiar. Linear being something of that nature where the exponent is to the first power. Quadratic, something like that where the exponent, leading exponent, is the second power. Okay. You may not be familiar with cubics. Okay, again, we're looking at leading exponents. Okay, the cubic is 3. Quartic is going to be probably guess it, to the 4th. And we can keep going, but we don't need to. These are all classified as polynomial functions. Okay. If we say polynomial, you know that's all those, and it goes on and on and on and on. We can just keep going forever. Okay. If you want a more formal definition, you can look in your book. This goes something like that. Okay. F of x equals x to the m. Okay, m is a real number. You also know, okay, a little vocab here. These are called coefficients. They're in front of the variables. Make a slight correction here. This can go on. Okay, it can be plus x to the m minus 1 and on, but m still has to be in the reals. The degree is the largest exponent, and sometimes you'll see it just referred to as m or n. Okay, leading coefficient it's just the coefficient on the term with the degree. Okay, and then the domain is the real numbers in polynomial functions. You probably could have figured that out. A couple others that you know from classes of functions. You know exponentials. Where the x variable is in the exponent, hence exponential. Wow, mathematicians really got that one. You know logarithmic. Okay, y equals log base b of x, where b is some real number. Graphs. Exponentials look like this. logs look like this. We're talking inverses. Okay, we'll get to that, but that's something that you'll know. Okay. Trigonometric you also know. Okay. So y equals sine x, and you can also include cosine, tan, secant, cosecant, cotangent in that. Many of the graphs look like this or like this. One of them also looks like this. Okay, so you'll learn all that. Just giving you a primer here. Okay. A few you might not know. Rational. When you hear rational in math, think fraction. Okay, so a rational function is some function over another function. Okay. And then be aware that for domain purposes, the bottom can't be 0 because you'd be dividing by 0. Okay. Those can take on any one of a number of different graphs. There's algebraic. Okay, this is the sum, product, quotient of roots of polynomial or rational functions. Okay, those would look something like this one out of your book. F of t equals 1 plus 3t squared. Okay, minus x t to the fourth. So that's an example. There are some more examples in your book if you would like to look. Okay, I think that covers it. So you got lots of vocabulary words there. We might also toss at you the inverse trig functions, sine inverse, cosine inverse. But I would include those in the trigonometric realm. All right. I think you should already have this down, but just to make sure, that's what we're doing, the preliminaries. We're going to go over it. You can combine functions in many ways. You can add them. So if I add two functions, it just means that I take their outputs. Okay, if f of x is 2x plus 5 and g of x is 3x squared plus 4x plus 2, f plus g is just adding them together. Okay, so 3x squared and then the x's go together. 6x, and those go together. Alright, so that's the end result. Please try to always circle your answers for me. Makes it easier.
You can have subtraction, multiplication, and division. Just be aware again, the domain g of x cannot be 0. Okay. All right, the important part of today is composition. It looks something like that. Okay, that looks familiar. So basically, we're putting g of x inside of f. So if I use my example up here with these two again, f of g of x is f of, and then I'm going to put g inside of it. Okay, which gives me, now f is 2x plus 5, so I have 2. Okay, so I'm going to put this here. So I put g inside of the x. Okay, that's the big idea. Put g inside of f. I also could do g of f, where I put f inside of g. So 3 times, so I just put, everywhere there's an x, I put f. Okay, and then simplify. Okay, here you would distribute, combine like terms, you're done. Okay. Be careful now with the domain. Like if you look in your book, this is your example. If f is the root of x and g is 1 minus x, okay, the domain of this is a set of x such that x is greater than or equal to 0. This one is a set of x such that x is a real number. But if I do f of g of x, I'm going to put this one inside, I get the root of 1 minus x. So the domain has actually changed to the set of x such that let's see here, 1 minus x has to be greater than or equal to 0. Negative 1. X is less than or equal to 1. So that's one way to do it. If you know that this has to be bigger than 0, set that up and solve it, and you got your domain. Okay, so be careful there. All right. That should do it. Again, this is the most important stuff. You gotta know the vocab, but we're gonna be doing this just about every day. Okay. Let me get 1.3 up here. Here's your work, and we are going to work on this in class tomorrow. 1, 4, 10, 12, 14 through 24, even, 27 and 28. Now this is where we start spiraling. So you have some work from 1.1, 23 and 52, and 1.2, 11 and 42. This is so I can give you help, you get some practice. It all shows up on the test, so you get more practice, more practice. These will be shorter now. The new stuff will be shorter. Now we're going to start doing anywhere from 4 to 10 problems, usually around 4 to 5 problems from spiraling, okay? If you don't do anything, these are more important. But these are, the first few here are important, but these are super important because they're practice. Okay. If you have any questions, bring them to class. Toodles. Come on.